Picture this. It's 1980 in Wyoming, and fuel prices have just doubled. Again, you're running a 5,000-acre ranch with a fleet of Dodge Power Wagons that barely squeeze 10 miles from a gallon of gas. Each truck burns through $30 of fuel every single day. Your annual fuel bill? $45,000. That's not profit margin. That's survival money bleeding out through your exhaust pipes. Most ranchers just accepted it as the cost of doing business. But Bob Morrison wasn't most ranchers. What Morrison did next would make Dodge engineers question everything they thought they knew about truck buyers. He took his perfectly good Dodge Power Wagons, trucks with strong 318 cubic inch V8s, and ripped those engines out. Every single one. His neighbors thought he'd lost his mind. The local Dodge dealer said he was destroying perfectly good trucks. But Morrison had discovered something in the classified section of a farming magazine that would change ranch operations across the American West forever. This is the story of how one Wyoming rancher outsmarted a multi-billion-dollar corporation, saved his ranch from bankruptcy, and accidentally started a grassroots engineering revolution that forced Dodge to completely rethink their truck strategy. Morrison didn't just modify his trucks. He proved that Detroit had been dead wrong about what working people actually needed. To understand why Morrison's conversion was so radical, we need to understand what the Power Wagon represented in 1980. These weren't just trucks. They were the backbone of American agriculture. Dodge had been building Power Wagons since 1945, evolving them from military workhorses into civilian ranch equipment. By 1980, the Power Wagon had earned its reputation as the toughest four-wheel drive truck money could buy. The Dana 60 front axle could handle anything. The new Process 203 transfer case was bulletproof. The frame was overbuilt to military specifications. Under the hood sat Dodge's 318 cubic inch LA Series V8. This engine produced 155 horsepower and 255 pound-feet of torque, respectable numbers for the era. The 3-18 was reliable, parts were everywhere, and any mechanic from Seattle to Sarasota could rebuild one with their eyes closed. It was the safe choice, the proven choice, the American choice. But here's where Dodge's engineers made their critical miscalculation. They believed ranchers and farmers chose trucks based on power and tradition. V8 engines were part of American truck DNA. Market research showed truck buyers associated diesel engines with slow, noisy, smelly semi-trucks and farm tractors. Dodge's product planners were convinced that offering a diesel option would actually hurt sales. Ranchers wanted torque, sure, but they wanted it delivered with V8 thunder, not diesel clatter. The 1979 energy crisis changed everything. When Iranian oil production collapsed, gas prices jumped from 65 cents to $1.40 per gallon. For Morrison, running 8 Power Wagons, averaging 10 miles per gallon, this meant his fuel costs exploded from $22,000 to $45,000 annually. That wasn't just expensive. It threatened the ranch's existence. Something had to change. Morrison's breakthrough came from an unexpected source. While waiting at a truck stop in Laramie, he noticed a Grumman bread delivery truck pull up to the diesel pump. The driver mentioned his truck had over 400,000 miles on the original engine. Morrison crawled under the truck and found a Cummins 4BT diesel, a 4-cylinder engine barely larger than a big suitcase. The driver claimed he was getting 25 miles per gallon in a truck that weighed 10,000 pounds loaded. The 4BT wasn't designed for pickup trucks. Cummins built it for industrial applications, delivery trucks, wood chippers, generators, agricultural pumps. It displaced just 3.9 liters, 239 cubic inches, significantly smaller than the 318 V8 it would replace. But the specifications told a different story than the size suggested. This engine operated on completely different principles than a gasoline V8. The compression ratio was 16.5.1, nearly double the 318's 8.7 to 1. When the piston reached the top of its stroke, it compressed the air to over 500 psi and heated it to 1,000 degrees Fahrenheit. No spark plugs needed. The heat alone ignited the diesel fuel when the mechanical injection pump shot it into the cylinder at 2,000 psi. The combustion pressure reached 2,500 psi compared to maybe 600 psi in the gas engine. The 4BT produced 105 horsepower at 2,500 RPM. That's 50 horses less than the 318. But torque told the real story, 265 pound-feet at just 1,700 RPM. The diesel made its peak torque 500 RPM lower than the gas V8, and it held that torque across a wider range. More importantly, it achieved this while burning 40% less fuel. Morrison spent 3 months planning his first conversion. The 4BT weighed 780 pounds, actually 50 pounds more than the 318 with all accessories, but it was physically smaller. Length measured 30 inches. Width was 24 inches. Height, including the oil pan, was 33 inches. It would fit, barely, but everything else would need fabrication. The transmission posed the first challenge. The 318 used a Chrysler 727 Torque Flight automatic or a new Process 435 4-speed manual. Neither would bolt directly to the Cummins. Morrison found his solution in medium-duty trucks, a SAE No. 3 bell housing adapter that would mate the 4BT to a rebuilt NP 435. The adapter alone cost $400 and had to be machined to precise tolerances. Motor mounts required complete fabrication. Morrison welded new mounting plates to the frame, positioning the engine to maintain proper driveline angles. Too steep and the U-joints would bind. Too shallow and they'd vibrate apart. The diesel's different weight distribution meant relocating the battery and reshaping the transmission tunnel. The cooling system needed complete redesign. Diesel engines reject more heat through the cooling system than gas. Engines, about 40% of the fuel's energy goes out through the radiator. Morrison installed a larger 4-core radiator from a 1-ton Dodge truck, added an engine-driven fan with a thermostatic clutch, and plumbed in an external transmission cooler. The original 318 radiator would have overheated in minutes. Fuel system conversion meant installing a 40-gallon diesel tank from a military surplus truck, running new fuel lines rated for diesel's different chemistry, adding a water separator, and mounting 2 fuel filters, a primary filter to catch water and large contaminants, and a secondary filter to protect the injection pump. The mechanical Bosch VE injection pump didn't need electricity to run. As long as the engine turned, it would pump fuel. The exhaust required careful engineering. Diesel exhaust runs cooler than gas, about 700 degrees versus 1,200 degrees at the manifold, but it carries more soot and particulates. Morrison fabricated a 3-inch exhaust system using aluminized steel tubing, positioning the muffler for maximum ground clearance. Electrical integration was surprisingly simple. The 4BT needed power for the starter, alternator, and shutdown solenoid. No ignition system, no computer, no sensors beyond basic temperature and pressure gauges. Morrison installed a manual glow plug switch for cold starts and wired in a tachometer that read the alternator frequency. The first start came after 6 weeks of fabrication. Morrison bled the fuel system, cycled the glow plugs for 30 seconds, and hit the starter. The engine caught immediately, settling into a characteristic diesel clatter at 750 RPM idle. Smoke cleared after a few seconds. Oil pressure showed 60 psi. Temperature stabilized at 180 degrees. But starting was just the beginning. The real test came with the first full day of ranch work, checking fence lines across rough terrain, pulling a 6,000-pound cattle trailer, climbing grades that touched 15%. The diesel power wagon felt different immediately. Less responsive at first, the engine needed a second to spool up. But once the turbocharger came alive at 2,400 RPM, torque came on like a freight train. Morrison discovered the diesel's torque curve matched ranch work perfectly. Creeping through muddy feedlots, the engine pulled from idle without lugging. Climbing hills with a loaded trailer, it held steady at 1,800 RPM, where the 318 would have downshifted twice. The engine brake effect was stronger too. Compression braking on descents meant less brake wear. But here's where it gets interesting. Fuel economy exceeded even Morrison's optimistic projections. Empty highway driving delivered 28 miles per gallon. Loaded with a ton of feed, it still managed 22. Pulling a cattle trailer, consumption stayed above 18 mpg. The 318 had never exceeded 12 mpg empty and dropped to 6 mpg towing. The math was staggering. Each converted truck now burned 3.5 gallons daily instead of 10 gallons. At $1.40 for gas versus $1.20. For diesel, daily fuel costs dropped from $14 to $4.20 per truck. Morrison's 8-truck fleet was suddenly saving $78 per day, $2,240 per month, $28,000 per year. The first conversion paid for itself in 4 months. But fuel savings were only part of the story. The 4BT's simplicity meant fewer breakdowns. No ignition system to fail, no carburetor to gum up, no vacuum lines to crack. The mechanical injection pump would run until the pump drive gear wore out, typically after 500,000 miles. Oil changes stretched to 10,000-mile intervals using 15W40 diesel oil. The only regular maintenance was changing fuel filters every 20,000 miles. Durability exceeded anything Morrison had experienced with gas engines. The 4BT's bottom end was massively overbuilt for its power output. The forged steel crankshaft weighed 45 pounds. Main bearing journals measured 2.98 inches, larger than big block V8s, making 3 times the power. The block used a deep skirt design with cross-bolted main caps. Cylinder walls were 0.375 inches thick. The head design prioritized longevity over performance. 2 valves per cylinder kept things simple. Valve springs were sized for 3,500 RPM maximum. The governor cut fuel at 3,200 RPM anyway. The cast iron head used induction hardening on valve seats. No need for lead additives or hardened seat inserts. Sodium-filled exhaust valves handled the heat. Head gasket failures were almost unknown if you didn't overheat the engine. Morrison's neighbors initially mocked the conversions. The trucks were louder than stock power wagons. They smoked on cold starts. They smelled like a school bus. They were slower off the line. But when Morrison shared his fuel receipts, attitudes changed quickly. When they saw his truck still running strong after 200,000 miles without rebuilds, mockery turned to interest. Word spread through the ranching community like wildfire. The local coffee shop in Wheatland became an impromptu technical forum. Ranchers compared notes on conversion techniques. Someone found a source for takeout 4BT engines from wrecked delivery trucks, $800 for a running engine with 150,000 miles. Another rancher discovered that international Scout transfer cases bolted directly to the adapted transmission. By 1982, Morrison was converting trucks for other ranchers. He streamlined the process, cutting conversion time to 4 days. A complete conversion cost $3,500, including the engine, adapter, fabrication, and labor. Compared to a new Power Wagon at $12,000, converting an older truck made economic sense. The conversions evolved with experience. Morrison learned to add sound, deadening to the firewall, adhesive-backed rubber and foam that cut interior noise by 8 decibels. He developed motor mount designs that reduced vibration. He found that advancing injection timing by 2 degrees improved power without hurting economy. A pyrometer to monitor exhaust temperature prevented overheating under load. Performance improved with modifications. Adding an aftermarket turbocharger from a 6BT, the 6-cylinder version, boosted power to 130 horsepower. An intercooler dropped intake temperatures by 100 degrees, adding another 10 horses and improving reliability. Turning up the injection pump fuel rate increased torque to 320 pound-feet, though fuel economy suffered slightly. The Dodge dealer in Laramie wasn't happy. They tried to claim the conversions voided warranties until Morrison pointed out the trucks were already out of warranty. They warned about safety issues but couldn't cite any specific problems. They insisted diesel engines wouldn't last in pickup truck applications, ignoring the evidence of Morrison's high-mileage fleet. Dodge's regional management took notice when Power Wagon sales dropped 30% in Wyoming and Montana. Dealers reported customers specifically asking about diesel options. Market research revealed a shift in buyer priorities. Fuel economy now ranked above horsepower for commercial users. The energy crisis had fundamentally changed truck economics, but Dodge's hands were tied by corporate politics. Chrysler Corporation was bleeding money, having just received a government bailout. They'd already committed to a new generation of Ram trucks powered by improved gas engines. Developing a diesel option would cost millions they didn't have. Besides, their marketing department insisted Americans would never accept diesels in light-duty trucks. Meanwhile, Morrison's diesel power wagons kept proving the marketers wrong. His 1976 W200 accumulated 400,000 miles on the original conversion. Compression tests showed less than 5% variation between cylinders. Oil analysis revealed bearing wear well within specifications. The injection pump finally needed rebuilding at 380,000 miles, a $400 job that restored like-new performance. The reliability advantage became even clearer during Wyoming winters. The 318s needed warming up before working hard, or they'd develop lifter noise and oil consumption issues. The diesels could be worked hard from cold starts. Their massive bottom-end bearings tolerated cold oil better. The mechanical injection system didn't care about temperature. Glow plugs ensured reliable starts down to -20 Fahrenheit. Morrison documented everything: fuel receipts, maintenance records, repair bills. His 8 converted trucks averaged 24.3 miles per gallon over 5 years. Maintenance costs averaged 0.03 per mile versus 0.08 for the gas trucks he'd kept for comparison. The diesels required 60% fewer repairs. Engine-related breakdowns dropped to almost zero. The Agricultural Extension Service took notice. They published a study on Morrison's conversions, validating his economic claims. The report calculated total cost of ownership over 300,000 miles, including purchase price, fuel, maintenance, and repairs. The diesel conversions cost $0.28 per mile. Comparable gas trucks cost $0.41 per mile. For a ranch running a trucks 40,000 miles annually, that meant saving $5,200 per truck per year. Other manufacturers were watching too. Ford engineers visited Morrison's ranch in 1983, examining his conversions in detail. They measured everything, took hundreds of photos, interviewed Morrison for hours about real-world performance. Within 6 months, Ford announced development of a diesel option for F-Series trucks. They partnered with International Harvester for a 6.9-liter diesel V8. General Motors wasn't far behind. They'd been selling diesel pickups since 1978, but their converted Oldsmobile 350 diesel was a reliability disaster. Head gasket failures, crankshaft breakages, and injection pump problems gave diesels a bad reputation. GM needed to see Morrison's Cummins conversions succeeding to understand they'd been using the wrong engine design. The conversion movement spread beyond Wyoming. Nebraska ranchers started swapping Cummins engines into everything: Chevrolet CK trucks, Ford Broncos, International Scouts. A cottage industry developed around adapter kits, wiring harnesses, and conversion components. Machine shops specialized in bell housing adapters. Radiator shops developed diesel-specific cooling packages. But the real validation came from Cummins themselves. In 1984, they introduced the 4BTA, a factory turbocharged version, making 120 horsepower and 295 pound-feet of torque. The engine was specifically marketed for agricultural and light truck conversions. They'd recognized the market Morrison had inadvertently created. The conversions influenced truck design in unexpected ways. Morrison's success proved truck buyers would accept less horsepower for better economy. It showed that torque at low RPM mattered more than peak horsepower for work applications. It demonstrated that simplicity and reliability trumped features and refinement for commercial users. Dodge finally capitulated in 1989. They introduced the first factory Cummins diesel Ram, a 5.9-liter inline-six, making 160 horsepower and 400 pound-feet of torque. The engine was basically a scaled-up version of Morrison's 4BT, using the same basic architecture and design philosophy. Initial sales projections estimated 5,000 units annually. They sold 18,000 the first year. The Ram Cummins became legendary for the same reasons Morrison's conversions succeeded: reliability that exceeded 500,000 miles, fuel economy that made financial sense, torque delivery perfectly suited to heavy work. Dodge marketed it as the truck that could pull down a house and get 20 mpg doing it. Morrison's impact extended beyond forcing Dodge's hand. His conversions proved that manufacturers had fundamentally misunderstood their customers. They'd assumed brand loyalty, V8 tradition, and horsepower bragging rights drove purchases. Morrison showed that operating costs, reliability, and fitness for purpose actually mattered more. The environmental impact, though not Morrison's primary concern, was significant. Each converted truck burned 2,000 fewer gallons annually. Morrison's 8 trucks alone saved 16,000 gallons per year. If just 10,000 similar conversions happened nationwide, a conservative estimate, that meant 20 million gallons of fuel saved annually. Lower consumption meant reduced dependence on foreign oil during a critical geopolitical period. The technical lessons influenced diesel engine development. Morrison's modifications, turbocharging, intercooling, injection timing advances, became standard on factory diesels. His focus on longevity over performance shaped how manufacturers designed truck diesels. The success of simple mechanical engines delayed the adoption of complex electronic controls until the 1990s. Morrison kept converting trucks through the 1980s. He developed techniques for swapping 4BT engines into older trucks from the 1960s, giving classic power wagons new life. He experimented with different transmissions, finding that Spicer 35.3A 5-speeds provided the best gear spacing for diesel torque curves. He even converted a 1946 Power Wagon, creating what might have been the world's first diesel flatbed truck. The economic impact on Morrison's ranch was transformative. Fuel savings of $28,000 annually meant the difference between profit and loss during tough years. Lower maintenance costs freed up capital for land improvements. The reliability meant fewer missed shipments and veterinary appointments. Morrison credited the diesel conversions with keeping his ranch operational through the 1980s farm crisis. Competitors took notice of Morrison's advantage. Neighboring ranches that didn't convert found themselves at a cost disadvantage. When cattle prices dropped in 1985, operations with high fuel costs couldn't compete. Morrison could afford to transport cattle further to better markets because his fuel costs per mile were 60% lower. The conversion knowledge Morrison developed had value beyond his ranch. He started teaching workshops, charging $500 for a weekend course on diesel conversion techniques. Ranchers flew in from Texas, California, and Canada to learn his methods. He published a detailed manual with step-by-step instructions, wiring diagrams, and part sources. The manual sold 5,000 copies at $45 each. Tool manufacturers noticed the trend. Specialty tools for diesel work became widely available. Injection pump timing tools, compression gauges reading to 600 psi, and glow plug analyzers appeared in parts stores. The aftermarket developed products specifically for conversions: oil pan adapters, exhaust manifolds, and gauge packages. The safety implications were significant. Morrison's diesels couldn't backfire through the carburetor because they had no carburetor. No gasoline meant reduced fire risk. The lower exhaust temperatures meant less chance of grass fires from hot exhaust. The engine's inherent flame-arresting properties made them safer around hay storage and fuel tanks. Insurance companies recognized these advantages. Some offered reduced premiums for diesel conversions, acknowledging lower fire risk. The mechanical simplicity meant fewer breakdown-related accidents. The engine braking capability reduced brake failures on mountain grades. Morrison's insurance costs dropped 15% after documenting his conversion's safety record. The story reached its climax when Dodge engineers visited Morrison's ranch in 1987. They came to understand why their customers were abandoning them for shade tree conversions. The lead engineer spent a day driving Morrison's converted trucks, pulling trailers, climbing hills, checking fence lines. He left with pages of notes and a changed perspective on what truck buyers actually needed. That visit directly influenced the 1989 Ram Cummins development. Dodge engineers incorporated lessons from Morrison's conversions, the importance of low-end torque, the value of simplicity, the priority of fuel economy for working trucks. They even hired Morrison as a consultant, paying him to review prototype designs and provide feedback from a user perspective. The philosophical implications were profound. Morrison had proved that innovation didn't require corporate resources or engineering degrees. A practical problem, mechanical aptitude, and willingness to experiment could outsmart billion-dollar corporations. His conversions demonstrated that users often understand their needs better than manufacturers understand their customers. Looking back, Morrison's weird diesel conversion represented something larger than saving money on fuel. It was about taking control of your tools, solving your own problems, and refusing to accept that the way things are is the way they must be. Morrison didn't wait for Dodge to offer what he needed. He built it himself, and in doing so, forced an entire industry to reconsider its assumptions. Today, diesel pickups dominate the heavy-duty truck market. Ram's Cummins partnership continues after 35 years. Ford's Power Stroke and GM's Duramax compete for diesel supremacy. Every manufacturer offers multiple diesel options. The market Dodge believed didn't exist now generates billions in annual revenue. Morrison's original converted Power Wagon sits in a museum in Cheyenne, still running after 600,000 miles. The placard reads, "The truck that changed trucks." It's a testament to what happens when practical necessity meets mechanical ingenuity, when one rancher's fuel crisis solution became an industry transformation. The lesson isn't just about diesel engines or fuel economy, it's about questioning conventional wisdom, solving problems with creativity rather than capital, and proving experts wrong through practical demonstration. Morrison didn't set out to revolutionize the truck industry, he just wanted to save his ranch. But by solving his own problem, he solved it for thousands of others and forced one of America's biggest automakers to fundamentally change their product strategy. That's the real genius of Morrison's diesel conversion. It wasn't just weird, it was prophetic. He saw what Dodge couldn't, that efficiency, reliability, and operating cost would eventually matter more than tradition, sound, and horsepower. He was right, and the modern truck market proves it every single day. What's your experience with diesel conversions or unusual engine swaps? Have you ever modified a vehicle in a way the manufacturer never intended? Drop a comment below and share your story. And if you enjoyed this deep dive into automotive innovation, hit that subscribe button for more stories of engineering rebels who changed the industry from the outside in.